Now, there is a technique that looks pretty much identical to PCA that tries to do exactly what you want to do, which is take advantage of class labels, right? So this is linear discriminant analysis, and the basic idea there is PCA looks for a dimension of the greatest variance. LDA looks for an interesting dimension such that when you project to that dimension, you maximize the difference between the means of the classes normalized by their variances. So you don't try to find the dimension of the greatest variance, that would be that, right? What you do is you try to find the dimension where sort of once you project to it, there is the greatest separation between the green class, right, and the red class. Now, so this is basically a version of PCA that tries to reduce the dimensionality in the way that is most useful for a classifier. Now, it does that by making several assumptions. So it assumes that the data is Gaussian, and it assumes that you have a simple boundary between the data points. So you could always come up with counterexamples, right? This is not bulletproof. You can come up with distributions of data where LDA is going to give a bad projection and PCA will actually give a better projection. So here's one example. If your data was distributed like that, so basically your red class had this mean, and it had a relatively circular-looking Gaussian, and then the green class had elongated Gaussian that way, right? So if you did LDA projection, LDA would look for the greatest difference between the means normalized by the variances, so it'll likely pick that direction, right? That's the direction that allows you to separate the means as far as possible. And of course, in this case, you can't separate the means very far. So if the separating information is not in the means, then LDA is not going to pick a very good projection. PCA, on the other hand, would project to the greatest variance in the data. So that's what the projection would look like for PCA. This would be the red class, this would be the green class. You cannot separate them with a single threshold, but if you had a nonlinear classifier, it would have no problem picking out the greens from the reds. So in this case, if you had a powerful classifier, a PCA projection would actually be better than an LDA projection. So you can always, basically, all I'm trying to say is LDA is not foolproof. You're not guaranteed to get higher classification accuracy if you run LDA, just like with PCA. Sometimes it'll help, sometimes it won't help. You have to experiment and see.